Now we will see one example on calculating moment of inertia of a composite section. Before starting this, I need to explain the parallel axis theorem again. So there is a rectangular section here, that is the area of this is A. If this is my centroidal axis, if I know my moment of inertia here, I can transfer it to here. Say my moment of inertia about this central axis is Ixc, or even sometimes we write Ix bar, whatever, yes, Ixc, Ix bar, that doesn't matter, symbol doesn't matter, that is as long as you know it. So if I know here, I can transfer it here. Then what about this axis, it will be say Ix, so Ix bar plus A d square. So whatever the moment of inertia at the centroid plus a times the distance square. That is the parallel axis theorem. We need to use this theorem to calculate the moment of inertia of a composite section. Say assume the, a composite section is a T section. So I have one rectangle here, other rectangle here. So assume a dimension, say this is 3 inch, here to here, say 8 inch, here to here, say 2 inch, and here to here, say 6 inch, and this is at the center. So what is the moment of inertia of this composite section? Now, moment of inertia means I must tell the axis. Is it x-axis or y-axis or both? So whatever, say at the beginning we are finding one by one. Say we need to find moment of inertia about x-axis, about centroid. Then moment of inertia about y-axis at the centroid. Then subsequently we can find polar moment of inertia, which is whatever you find Ix plus Iy. Or you can find radius of gyration about x-axis, which is Ix bar by A. This way you can find so many parameters, but the most important parameter is these two. Once you find these two, you can find everything. Okay, so we will do it Ix bar. Ix bar means moment of inertia about x-axis. X means horizontal, bar means through the centroid. That means whatever my centroid here, say my centroid is here, that will be my Ix bar will be about this axis. So our first step for composite section is to determine the centroid. This is why it is very important, and before starting this class we finish centroid first. Okay, so how to find centroid? We need to divide, say this is number 1, this is number 2, and say and first of all x bar or x component of the centroid of this section is at this line. We know that because it is symmetric. There's a line here. If I fold it, it will be overlapped perfectly. So my x bar is here. I need to find y bar. So how to find y bar? So y bar is y1, a1, y2, a2, a1 plus a2. So what is my y1? Y component of centroid for part 1. So part 1 is this portion. So it is a rectangle. So what is my y1? Half of this, 4. So 4 is. What is my area 1? That is area of part 1. So 2 times 16. So it's 2 times 8. 16 inch square. What is y2? Say y component of the centroid of part 2. Part 2 is here. Centroid is at the middle. That means it is 3. So 3 by 2, 1.5. If this is my reference point here, then 8 plus 1.2. That means 9.5. What is the area of this portion? 6, 3, 18 square. So then 16 plus 18 inch square. If I use my calculator very quickly, 4 times 16, 9.5 times 18 divided by 16 plus 18, I found 6.9 is. There's some fraction, forget the fraction. That means my centroid is somewhere here, yes? Somewhere here, and this portion is 6.9 inch. Okay, so we found it, centroid. Okay, then I will erase this portion because it is done. Oh, maybe I need this value sometimes later. Okay, whatever. So let us find that first one, moment of inertia about centroidal x-axis. That means this axis. Now I have two parts. One is this, one is that. So what I will do, we will go part by part. See, if we do part 1, what is the moment of inertia of part 1? If I draw here again, we know the centroid of part 1 about its own centroid. So this is 2, this is 8. So this is 2 times 8 cube over 12. If you can remember, so Ix is BH cube over 12. But this BH cube over 12, this moment of inertia is about its own centroid, not the combined centroid. So what we need to do, its own centroid is, if I use a different color, its own centroid is here, here to here, that is 4. So its own centroid is here to here is 4 inch. But I need here. What to do? I need to transfer here to there. So what I will do, whatever value I know to transfer here to there, I need to add, say I need now here. If I need here, I will transfer here to there. How? I will add, okay, write it here. So 2, 8 cube over 12, I need to add AD square. So write here AD square. Now AD square, I need to find this distance. So what is my A? A is very simple, area of part 1. Area of part 1 was 16. I know A. A is done in this square. What is my D? D is y bar minus y1. That means if I write this portion, it is y bar minus y1. Now, do not get confused about the sometimes like the sign. Sometimes people write y1 minus y bar. Is it a mistake? It's not a mistake, but it will be just a negative sign. So sign doesn't matter because it has a square here. So you can write y bar minus y1 or y minus y bar, whatever you write, it will represent this distance. Sign doesn't matter. So I write this y bar minus y1. And why I am telling it y1 minus y bar, I will tell you later. Okay, so simply, sometimes we, okay, if I simplify, sometimes we write this way. So b1 h1 cube divided by 12 plus a1 y bar minus y1 square. So this portion sometimes we write this way to make it simple. What is this? B1, that means B for part 1, H for part 1, 12, A1 is the area of part 1 times D is y bar minus y1 square. So sometimes we write this way. Okay, so if I make some room here, okay, similarly for part 2. So what is part 2? If I write here, so this is my part 2. We know the moment of inertia about this axis. This is 6, this is 3. So, or write this way. about this axis is B2H2 by 12, but I need to transfer it to here to here. Okay, now here to here is Y2 and here to here is Y bar. Then if I need to transfer here to there, what I will do? I will add AD square. So here B2H2 by 12 plus A2 Y bar minus Y2 square. So what I am doing, whatever I found at its own centroid plus A2, this distance square. This distance is Y bar minus Y2 square. Now you can see Y bar is this, Y2 is this, that means this part is bigger, so this will be negative sign, this is square, so no problem. So for this kind of things, this minus that or that minus this doesn't matter. Okay, so what can I do? You can do it manually like this plus this, or find it very quickly. So if I want to find, okay, find this portion first. So B2 is 6, 3 cube plus 12, area is 18, 6.9 minus 9.5 square. And here you found 2, 8 cube by 12 plus A1 was 16, Y bar 6.9 minus Y1 was 4. This. So your combined I will be this plus that. So your combined I about the combined centroid will be whatever you found here plus whatever you found there combined. Now, do I need to do the calculation? I think you can do your own calculation, like calculate this plus calculate this, whatever it is. Do not forget the unit. The unit here is inch, so combined unit will be inch to the power 4. So do not forget the unit. Okay, the reason I am going here, I will simplify it more. So for composite section, sometimes without understanding anything, we write this way: B1 H1 cube by 12 plus A1 Y bar minus Y1 square plus B2 H2 cube by 12 plus A2 Y bar minus Y2 square. So sometimes we just write our equation this way. Sometimes we write our equation this way. In that case, you do not need to think so much. Or you can do one by one. So if I do it, what is B1, 2, H1, 8, 12, A1, area of this, which is 16, Y bar 6.9, Y1 4, plus B2 6, H2 3, 12, A2, area of this portion, which is 18, Y bar 6.9, Y2 9.5. Then you can find it. So these are the two different ways. One is you can do it this way one by one and add. Other one is this way. Okay, so hopefully you understood Ix moment of inertia of this composite section about x-axis. What about for y-axis? Okay, so I will make it clear. So if I do not forget, my section was similar to this. This was how much? 2, I think. This was 8. This was 3. This portion was 6. Now we need to find moment of inertia about y-axis. Y-axis means this axis. Y-axis. Now again, what is the Centroid is here, we know that. Now if I divide here, this axis or this central axis is also the axis of this section 2. I say this is 1. That means if I draw 1 here, the y axis is here, its own y is here, combined y is also here. So I do not need to transfer it anywhere. So what is iy bar? It is iy1 plus iy2. So we will add these two. What is moment of inertia of this about y-axis? B h cube by 12, or a is b cube. That means this times this cube by 12. For y2 b, sorry, this times this cube by 12. So 6 cube by 12. Done. Whatever you get is to the power 4. So here I do not need to transfer it to anywhere, because the y component of the centroid of 1 and 2 is same as the y component of the centroid of the combined section. Okay, so hopefully you understood how to find moment of inertia about x-axis and y-axis of a T section. Now this is the same principle for any kind of composite section. Okay, so I will stop here. You can go to your book and solve more problem, and then you will understand better. Thank you.